two projectiles A and B thrown with speeds in the ratio 1:√2 acquire the same heights. If A is thrown at an angle 45 degrees with the horizontal, then the angle of projection of B is to be calculated. So when a projectile is thrown with a velocity v, making an angle theta with the horizontal, then the two components of velocity of the projectile can be written as the vertical component would be v sine theta and the horizontal component would be v cos theta. And when the projectile reaches its maximum height, its horizontal velocity remains unchanged, but its vertical velocity has become 0, and therefore the velocity of the projectile at the highest point would be equal to simply v cos theta. So now what is the potential energy difference between the point of projection and the maximum height? That would be mgh. The particle has gained mgh amount of potential energy in going from the point of projection to a height h, which is a maximum height, and it has lost some kinetic energy, which is equal to 1/2 m v square minus 1/2 m v cos theta whole square. This is the difference in kinetic energy of between the point of projection and the point of maximum height. So this simplifies to h is equal to v square into 1 minus cos square theta divided by 2g, or h is equal to v square sin square theta divided by 2g. Now we are given that HA is equal to HB and VA by VB is equal to 1/√2. So using the expression h is equal to v square sin square theta by 2g, we can say that VA square sin square theta A divided by 2g is equal to VB square sin square theta B by 2g. So 2g cancels out and we have VA by VB whole square sin square theta A is equal to sin square theta B, and the left hand side is VA by VB is 1/√2, so the square of that is 1/2, and theta A can be replaced by 45 degrees, and sin square 45 degrees is 1/√2 whole square, or 1/2, and this is sin square theta B. Hence sin theta B is equal to 1/2, or theta B is equal to 30 degrees, and hence option C is the answer. There is another intuitive way of looking at this, but it would not actually give us a numerical value. But if we know that B has a larger total velocity, then we can deduct that it has to be thrown at a shallower angle to make the same height, and the only one of the options that satisfies this condition is C. Option A would not achieve any maximum height at all. So intuitively we can just say that any angle lower than 45 degrees is a possible answer.